So this one we're going to talk about combustion. Combustion is when you take a hydrocarbon, which is just like a hydrogen and carbons, or sometimes instead of calling them hydrocarbons, they call them fuel. The easiest one I can think of is actually methane. Methane is one of those ones I said you should memorize. So methane is a type of gas. Okay, in order for there to be combustion, you have to have oxygen. So you can't have a fire, you can't have burning something unless you have oxygen. So again, like think of like Naked and Afraid or Survivor, right? You can't start the fire without the oxygen. The other one is, remember that I gave the example of class of like having a candle, and if I put a jar over top of it, what happens to the lit candle? Well, it goes out, right? Because it runs out of oxygen. So oxygen is kind of like a red flag saying, hey, this is a type of combustion reaction, so that you know that it's combustion because it has oxygen here. The other one is hydrocarbons. Hydrocarbons are things that we burn. So there are things we burn in our house for fuel. There are things we burn in our car for fuel. Those are typical types of fuel that we use. The things that we make here are always going to be carbon dioxide and water. So in these combustion reactions, the nice thing is that you don't actually have to use your periodic table at all, I would say. There would be no reason to look at the table, because if I know that methane is combusting, for instance, I'm going to write CH4O2 making carbon dioxide plus water, like this. Okay, and all I have to do is balance them out. So I'm going to write CHO, CHO. If I count over here, I have 1 carbon. If I count over here, I have 4 hydrogens. If I count over here, I have 2 oxygens. If I count here, I have 1 carbon. If I count here, I have 2 hydrogens. If I count here, I have 3 oxygens. So now what I'm going to have to do is get it to be the same. So let's start with the carbons are the same already. So let's go to the hydrogens next. So the hydrogen is at 4 and this one's at 2. So I'm going to put a 2 in front of here. Okay, that makes the 4. Now I look at this. This has changed the oxygen though. So I have 2 oxygens in here and I have 2 more oxygens in here. So that is 4 oxygens in total. So that means that I need to put a 2 in front of here, because 2 times 2 gives me 4. So now I have it balanced. Okay, let's try another one. So how about this one? C6H6 plus, how about if I just write down it was burned, but you know that it's oxygen. So if the beginning of the reaction looks like this, where you have a hydrocarbon and you have oxygen, that's like ding, 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 it is combustion reaction. So you should be writing out CO2 and H2O as the products. Okay, and then see if you can get it to balance. So if you need to pause the video now, go ahead and pause the video. Make your little chemistry bookkeeping lists and see if you can get it to balance. So write out your little list underneath and see if you can get it to balance first. So on the reactant side, I see 6 carbons, I see 6 hydrogens, I see 2 oxygens. On this side, I see 1 carbon, I see 2 hydrogens, and I see 2 oxygens here and 1 more here, so that makes 3 oxygens. Okay, now we need them to be the same. So let's start with carbon. So to get 6 carbons, I'm going to put a 6 in front of here. Okay, that makes this 6. In order to get the 6 here, I'm going to put a 3 in front of here because 3 times 2 gives me 6 hydrogens. Okay, now this has changed the amount of oxygens I have here because this is 6 times 2, that's 12 oxygens, plus 3 more oxygens in here. So altogether I have 15 oxygens. So right now I have 15 oxygens. Now if I look over here, is there any number that I can write that will make 15 oxygens? So any whole number that when I multiply it by 2 will give me 15 oxygens. And the answer is no, there is not any number that does that. So in order to do this, what I'm going to have to do is I'm going to have to do the combustion magic, which I call. So this 15 is the magic number. We're actually going to put it here. So we leave the oxygen alone once I put the 15 there, and we're going to double everything else. So because this doesn't have anything written here, this is actually a 1. So we're going to double it. So now it's 2. I'm going to double this one, so now it is 12, and I'm going to double the number in front of hydrogen, or sorry, in front of water, so that it is 6. Okay, now if we go back and count, so if we go back and count, we have 2 times 6, that is 12 carbons. How many hydrogens are there? There is 2 times 6, so that is 12. If I count how many oxygens I have right now, there is 30 oxygens on the reactant side. Okay, now we're going to count over here. So I'm going to erase my little arrows from before, maybe. Okay, so let's count how many carbons we have here. So 12 times 1 gives me 12 carbons. 6 times 2 gives me 12 hydrogens. So far this checks out, right? I have 12, 12, 12, 12. Okay, now let's check the oxygens. So I have 12 times 2, so that's 24 oxygens in that one. And then I have 6 times 1 oxygen, so I have 6 more oxygens here. So I have 30 oxygens. And look at that, it balances out. Okay, let's try another combustion reaction. Okay, the question will read like this. Nonane, which is C9H20, is burned in the air. And then it'll be like write out the reaction. Okay, couple things. This says burned. In order to burn anything, we need oxygen, and oxygen has to be on the reactant side. This is a hydrocarbon. This has to be over here. Oops. This is what is being burned. Okay, now because this is a combustion reaction, what I'm going to see is that I make carbon dioxide and water. So now what I'm going to need to do is balance the reaction. So if you need to pause the video here, I want you to do that, and I want you to figure out how many carbons and hydrogens and oxygens you have on each side of the equation. So over here I have 9 hydrogens. Over here I have 20, sorry, I said 9 hydrogens, but I meant 9 carbons. Here I have 9 carbons. Here I have 20 hydrogens. Here I have 2 oxygens. Here I have 1 carbon, 2 hydrogens, and I have 2 oxygens here and 1 here, so I have 3 oxygens in total. Okay, we need the numbers to be the same. So let's start with the carbon. So I need 9 on this side. So I'm going to put a 9 in front of here. Remember again that you can only put coefficients in front. You cannot put numbers in between things. You cannot make subscripts, right? You have to put the numbers there, so that in front, so that you're making the coefficient. My pen just died, so that was interesting. Okay, let's try that again. So we have 9 now, so this changes to a 9 over here. Now I need 20 hydrogens, so for there to be 20 hydrogens over here, I'm going to have to put a 10 in front of here. So 10 times 2 gives me the 20 hydrogens now. Okay, let's count the oxygens. So I have 9 times 2, that's 18 oxygens, plus 10 more oxygens. So that gives me 28 oxygens. So 28 oxygens is what I need. Is there a whole number that I could put in front of here that when I multiply it by 2 gives me 28? And the correct answer is yes. I could put 14, right? And that would give me 28. Okay, let's try another one. I think we should try a trickier one now. So we should try like glucose burns. So this is sugar, the simplest sugar. For it to burn, you have to have O2. You're going to make carbon dioxide and water. In order to get them to balance, you have to have 6, maybe you should write out the list. Okay, I'm going to say pause the video here, try it on your own, see if you can get it to balance. I would be careful with the oxygens afterwards. Just remember that there is 6 oxygens in this one here. Oh, come on, pen. 6 oxygens in this one here. So we need to make sure that we're accounting for that when we come back to there. So you can pause it and see if you can get it to balance first. Okay, I'm going to start. So there's 6 carbons on the left side. There is 1 carbon over here. There is 12 hydrogens over here. There is 2 hydrogens over here. Right now there is 6 carbons here and 2 here, right? So that makes 8 oxygens altogether. I think I just said carbons. I must be getting loopy. There is 2 oxygens here and 1 oxygen here, so there's 3. Okay, so now we need it to be the same. So this has 6, this has 1. In order for me to get 6, again, only using coefficients, I'm going to put a 6 in front of here. That changes this number to 6, so that we're okay. Now I need to get 12 hydrogens, so I'm going to also put a 6 in front of here because 6 times 2 gives me the 12 hydrogens that I needed. So now counting the oxygens, I have 6 times 2, so that's 12 oxygens, plus 6 more oxygens, so that's 18 oxygens that I need. Okay, now here's the thing, is usually I'd say, okay, well I need 18, I'll just put 9 in front of here. But if I do put 9 in front of there, do you notice that I get 18 here? Yes, that's true. But I also have the 6 from here. So in fact, I actually have extra oxygens, right? So I have actually like 24 oxygens, which is too much. I only needed 18. So instead of that, what we're going to have to do is we're going to have to figure out something else. So we're going to have to figure out what we could do instead of putting 9 in front of here and still get the 18. So instead, what if I said, okay, I need 18, but hey, I have 6 here already. So let's subtract the 6. So that gives me 12. So now I really only need 12 extra hydrogens. So the magic number that I should be putting in front of here is 6, because 6 times 2 is going to give me the 12 that goes there. Okay, I'm going to find another one. Okay, so we're going to try this one now. So this is propanol, the type of alcohol. You want you to see that first off that this is still a hydrocarbon even though it has carbon and hydrogen and oxygen in it. It is still a type of fuel. It is still undergoing combustion. I also have oxygen here, which is a red flag, right, for also that it is undergoing combustion. Okay, so I want you to even pause it here and see what you can figure out. See if you can figure out what the two products are going to be. See if you can figure out the balancing of it. I want you just to note that this one does have an oxygen in here, so be careful with the balancing of the oxygen afterwards. Okay, I'm going to start to count my reactants. So there's 3 hydrogens, there's 7, 8 hydrogens, 3 carbons. Did I say hydrogens again? 3 carbons, 8 hydrogens. There is 2 oxygens here, and there's also another one here. So there's actually 3 oxygens in total. A little bit tricky to count that side. This one is pretty normal now. I think we're getting to this is 1, this is 2, and if I count the amount of oxygens, I have 3. Okay, so starting with the carbon and getting the carbon to balance. I'm going to put a 3 in front of the carbon. That makes this 3. I'm going to put a 4 in front of here. And this will make this 8, right? Because 4 times 2 gives me 8. So this checks, this checks, this checks, this checks. Okay, and then I'm going to look at the oxygen, because the oxygen cannot be 3 anymore. The oxygen is now 3 times 2, right? That's 9 oxygens in this one, plus 4 more oxygens from that one. So I have this weird number, which is 13 oxygens. Okay, now normally I would say, like, if this is an odd number, it's not going to work, right? And I usually have to double everything. But I have to remember that in this case, this has this in it over here, right? So I need 13 altogether. Right now I have 3. I have 1 in here, so I'm going to subtract the 1. Now I actually only need 12 extra. Okay, so if I only need 12 extra, what number could I put in front of here to make that 12? So the answer would be 6. Okay, so this is combustion reactions. There is a lot more on that review worksheet, so you should practice. The answer key is also on Canvas, so you should practice that again. Make sure that you can recognize a combustion, make sure that you can recognize a formation, make sure that you can recognize a decomposition reactions, because those things are going to help you. And again, if you have not practiced the ionic naming worksheets that we gave out at the beginning, or the covalent worksheets at the beginning, you really need to get on those and practice those too, because that will make a heck of a difference. The next reaction that we're going to try is single replacements.